Okay, good evening all. So as I promised, I'm giving you the discussion of the question 1, 2, 3 and also your formative practice 2.2. Okay, all right. So the first question, an object moves with 50 meter moves 50 meter in 10 seconds with constant rate, meaning to be this is how many meter in how many second. So then it stops for 5 seconds before returning back to its original position in 15 seconds. So you are about to sketch the displacement time graph. So the first thing you draw, okay, sorry my drawing is not so good, time, second, origin, displacement, meter. Okay, this is the first thing. And then they mention what? 50 meter. So agak-agak this is 50, and then in 10 seconds. So you need to divide them for 5 second, 5 second and 5 second. So 5, 10, 15, 20. So why I said so? 10 plus 5 plus 15. So almost 20. So what you need to do? Okay, 50. Okay, so constant rate, and then stops for 5 minutes. That is your 5 minutes, and then before returning back its original position in 15 minutes. In 15 minutes, so this is 5, 25, 30. Okay, so 5, 10, 15. So this will be your final position. Okay, so this is your graph later. Okay or not? All right. Okay. Then second one, same answer, same question. In velocity time graph. Okay, so again velocity time graph. So there is a thing that you need to find out, your gradient. So what is your gradient? So find the gradient first. Okay, so this is your A, this is your B. So add your A. Okay, let it be here B, here is C. So your A, what is your gradient? It's a positive gradient, right? So 50 divided by 10. So what you get? Okay, 50 divided by 10. So you get 5 meter per second. So B, no gradient, so -1. Sorry. Your C, is again 50, -50 divide by in 15 seconds. So what you can do? What will be your answer? Okay, so 50 divided by 15. So you got 3.33, -3.33 meter per second. So drawing, sketching your velocity time graph. Okay, meter per second. Your time in second, your origin. So what you need to do? Okay, first you have 5. Okay, since it has negative, right? So you need to draw a graph which is also showing the negative part. Okay. Velocity meter per second 0. I'm very sorry, my screen is too sensitive. Okay, then this will be your time second. So here is 5, here is 3, here is 5, so almost here lah, huh? Okay, so then how long? First 10 minutes, first 10 minutes, right? Second 5 minutes, then 15 minutes. So 5, 10, 15, 20, 25, 30. So what you can do for first, okay, this is your line. Second 5 minutes, then third over here 3.37, 3.33. Okay, so it will be then this will be your velocity time graph. Okay, so 10, 15, 30. Okay, can I? So the next question, okay, the next question, let's check. All right. Okay, starting at point A, object moves at constant velocity for 10 seconds towards point B, then stop for 10 seconds at B. Then the object return back to its original position and reach point A after 5 seconds. Then it moves and reach the point C after 15 seconds. So they already give you the information. What is the distance between A, B and C? Okay, so sketch the displacement time graph. Okay, since it's move and reach, you have to see. So it goes here, then return back, then continue. So meaning to be your graph is going to have negative side of the graph. So meaning to be, okay, so 0, and then this is your S, meter, time, second. So point A, an object move at a constant velocity for 10 seconds. Okay, let's say this is your 10 seconds. Okay, 10 seconds. So how long? 20. So 20. Okay, 20. And then towards point B, then stop for 10 seconds. Another 10 seconds, should be 20. Okay, another 10 seconds at B. Then the object return back to its original position and reach the point A after 5 seconds. So meaning to be returning back 5 seconds. If this is 30, then this will be your 5 seconds. Okay, 5 seconds. Sorry for the messy. And then after that it moves back, moves and reach point C after 15 seconds. How long? 10 meter. So here would be your 10, negative 10. Okay, then it will be, because it's continue, you see, on your right hand side, on your left hand side. So 30, 40, how many seconds? 15 seconds, 5, 10. So this will be your point. So this will be your displacement. Okay, so now second one, sketch the velocity and time graph. Okay, you see here you need to know what is your gradient. Okay, what is your gradient? So you need to find out what is your gradient. This is your A, B, C and D. What is your A? Okay. Okay. What is your A? You calculate. So 20 divided by 10. 20 divided by 10. What do you get? 2. 2 meter per second. Okay, B 0. C, okay, C, what you going to get? How long it's written back? It's 5 seconds. So 5 seconds means 20 divided by 5, you get 4. 4 meter per second. How about the D? D is negative part, right? Okay, D is negative part. How long? It's 15 seconds. What is the distance? 10 meters. So 10, negative 10 divided by 15. So it's going to be negative 0.0.66 meter per second. Okay, so this is the information that you needed. Okay, so now we are going to do the sketch. Okay, you have negative, so remember you are going to draw a negative part, so make sure you have this information. So origin, velocity, meter per second, okay, and then time, second. So first part, 2 meters. You have 2 meters. Okay, remember here got negative, 2 meters. So 2. Then you have 4. You have 4. Then you have 3, 2, 1. Okay, then now you see, okay, first 20, 10, 20, 30 and 40. Alright, so what you need to do, at first you have this. Okay, sabar je lah. Okay, so next then you have this. Okay, this one, sorry, and then C part is 4. So okay, how long? In 5. Okay, over here in 5. Okay, so five, 4, then negative and here. So how long? 15 seconds. So this is your 15 seconds. So almost over here. See? So this will be your velocity time graph. Okay, number 3. Okay, number 3. Question number 3. Okay, an object moves from rest from rest with a constant acceleration in 10 seconds. Then the object maintain the velocity for 5 seconds. Then the object continue to decelerate at constant rate to the rest after 10 seconds. Okay. Now they ask you what? To sketch the displacement time graph. Okay. Now displacement time graph. How to do this? Okay, we might not know what is the informations that they are going to ask, because they did not give you any information on okay, let's do something like this. Okay, from rest, okay, from rest with a constant acceleration in 10 seconds, so increasing. Okay, so what is the okay, let's redo the velocity time graph first. Okay, velocity time graph first. What you have, informations 10 meter per second. Okay, if question comes like this with no idea what is the distance developed, then you start with the velocity first. Okay, so this is your graph. Okay, sketching velocity, meter per second, time, second, origin. Don't forget this. And then first they mention in 10 seconds. So approximately 10 seconds. So 10. Okay, here is 10. Here is 10. So this will be your first part. Second, the object maintain the velocity for 5 seconds. Meaning to be same 10 5 seconds, so this will be your 15 5 seconds. Then the object continue to decelerate at constant rate to rest after 10 seconds. So you need to add another 10 seconds. That means 15 plus 10 25. 15 plus 10 is 25. So this is 20. So this is 25. Okay, so meaning to be from here it will be your 25. Okay, so this is the information given. Alright, because why? Because they said decelerate, so it's a negative negative acceleration lah, negative direction lah. I mean, negative means got two meaning. One is slowing down, another one is changing the direction. So in this case, they are actually slowing down. Okay, because it comes to rest. Okay, from here, you can go back to the first question where you can remember how to, you can sketch what is the total displacement that actually are being distance or displacement being traveled by that object. Okay, so the first thing, remember this is velocity time graph, so you need to know what is the graph under what is the area under the graph. So here A, B and C. What is your A? 10 times 10 divide by 2, 100 divide by 2. Okay, so 100. Okay, plus, okay, next is B, 10 times 5, 50. Okay, and then plus negative 10 times 10 is 100. Okay, now in this case, you see, first, okay, you draw a line as meter 0 time per second. Okay, at first 10 minutes. Okay, sorry, 10 seconds. Okay, it's travel how long? 100. Okay, 100. Let it be 100. Okay, and then after that 50. Okay, plus 50. When you plus 50, it become 150. Okay, so in how many seconds? 5 seconds. Hey, 5 seconds. Okay, 5 seconds. So here you have, and then another 5 seconds. So you see that are the points. And then afterwards you have to add, because they are traveling, right? Okay, still traveling, plus 100. So plus 100, you will get another 250. Okay, how long? 10 seconds. So another 10 seconds here means yalah, another 10 seconds. Okay, 1 2 3. Okay, right. So if you see, the pattern will be something like this. Okay, so this is how we do the displacement time graph. You don't think because it's negative you cannot add on. It's not like that, because they are actually traveling there. Okay, traveling covering the solution. It's just changing the direction. Okay, right. Doesn't mean it goes down. It's remain on top. Okay, and then sketch acceleration time graph. Okay, you see acceleration time graph. Look at over here. Okay, so you need to find out the gradient. What is your gradient? Your A part, what is your gradient? So 10 minus 0 divide by 10, what you get? 1 meter per second. So at your C, your B don't have any gradient, so leave it. So your C, it's again 0 minus 10 divide by 10, right? Another 10 second. So negative 1 meter, okay, per second. Okay, so what you can do, so you have two parts. One is acceleration meter per second, origin t second. So if on positive side is 10, negative side also negative 10. Sorry, it's not 10, it's 1. Okay, it's 1 and negative 1. So what you can say here, 1, how long? It's 10 minutes. 10, 20 and 30. So here 1 for 10, 20 and 30. And then afterwards, for how long it remain? For 5 seconds. So here 5 seconds. Maybe I use different color. Okay, so first, then 5, then second one, how long? 15. Okay, for 10 means over here, so meaning to be until here. So this will be your graph. Okay, clear? All right.